Hi everybody, welcome to the third video of the ecosystem series. So in this series we build an ecosystem completely. I think we will build almost completely inside JavaScript, and we will build an ecosystem where there are some creatures that move around, and they will probably have some abilities and some goals, and they will kind of move according to a certain goal. I still don't know how this is going to look in the end, but I have kind of an idea. So this is what we've got so far. There are a bunch of circles moving in our two-dimensional world, because we are using orthographic projection with Ortho 2. And yeah, this is basically it. There are some circles moving around, and this is all developed inside JavaScript. We created a vector class and we created a creature class. Okay, so let's start with a bunch of improvement from last session. First of all, I will actually like to improve my frame rate. So FPS 120. In order to see if there are some parts of the code that are kind of making it super slow, we will be able to see this through the frame rate. As you probably realized, when I make the frame rate higher, my particles go faster, because the same calculation is done in more frames per second. So this we will correct in the future. So we will make kind of independent from the frame rate, the speed. But for the moment, let's just set it manually. So max speed, I will actually make this smaller, so 0.005. A bit faster maybe. Alright, so they have an initial velocity, these particles, and this is set by multiplying some random numbers for this max speed property of the class creature. By the way, I'm using Atom as an editor. I gave the auto watch parameter here in max, and so I can just save in Atom, and this will be updated also in max. Now let's go on with a series of improvement. The first one that I would like to do is to actually take our old vector class and put it in another file, which will include inside this JavaScript file. So to have a bit more kind of neat code. So let's create a new file. Let's save it as vector class.js in the same folder where we have our max patch and the other JavaScript file, and I will just paste our vector class here. Very good. Now here we have to include our vector file. So let's go on with include, and then the name of our file, so vector class.js. And since they are in the same folder, this should actually work. Yeah, so as you can see, it actually worked. So now all the functions, so our vector class will be accessible from this other file, but will be on another file of its own. So this is pretty cool, because this allows us to get our code pretty neat without messing it up. Okay, then let's do another little improvement. As you can see, when I enlarged the window, but then I saw again, naturally the particles are not related, are not going anymore to the boundary. So I save inside my Atom file, and the particles don't go actually to our full window, but they just stop at -1, because our default window ratio is 1. So it would be cool to make it in a way that when we save, it actually updates our window ratio. So this we can do pretty easily. Let's just create this function, mass named, and this will send a message to a receive object inside the max patch. So let's create this. Let's create this receiver name. So this we will call the ratio bang, and then let's send a message which will be a bang. So let's see if this worked. Let's create a receiver called ratio bang. So the same name of our message, our string here, and let's see if this works. So now that I save, it should actually send a bang, and yes, it seems that it's working. So every time I save the JavaScript now, this function will be executed and send a bang here to the receiver ratio bang. Actually, let's call it like save bang, something like this. If you have a name that makes more sense, please go for it. So, all right. Then other improvements. First of all, the size of the frame circle around, so the black circle around our circle, let's actually just do it the same size as our creature. We can actually also make it a bit bigger by giving a bigger line width to GGL sketch object. As you can see, we can start to see that this is actually a circle made of little segments, but this is okay. So in this video, we are going to create the code for getting the collisions of the particles. So we will check when two particles are colliding, and we will kind of make them bounce one from the other. So let's see if we can achieve that. Now, first of all, we need a function in our vector class to get the distance between this vector and another vector that we give as an input. So let's actually create this function here. So in our vector class, so I'm in the vector file, and this is a function which we will call this.dist equal function, and this will get another vector as an argument. So let's write v, and the distance function will go like this. So return the square root, so math square root of this.x minus b.x squared, so multiplied by the same value. So this will be the square value of this plus, and now let's actually copy that. So this is basically the Pythagorean Theorem. So we are simply getting the distance between these two vectors and then getting the square values and then adding them together and then getting the square root of all these. So this dot z, we're not using the zeta value for the moment, but it's always good to prepare our vector class to handle also a zeta value. Okay, so this should be it. So this dot x minus vector dot x multiplied by the same, so squared, and then the epsilon squared and zeta squared. Okay. So, alright, let's actually make it a bit bigger. Okay. Okay, now what we could use is also a function that gives us the distance, but without the square root, because the square root actually takes a lot of performance from our computers, so it will be cool to have actually the same function, but without the square root. So this will actually, let's just copy it, the function that we just wrote, and call it dist squared. And this will be actually the same code, but without the square root. Okay, so we can just write it like that. Alright. So let's actually also, inside our ecosystem.js file, let's actually create an ecosystem class which will kind of group together all the main functions that we call. For example, like update, display. This we will do in a POSIT class called ecosystem. So let's create the new class, ecosystem class. Okay, so let's go like this, function ecosystem. We write it with a capital E because this is a class. And then let's give it some properties. Actually, yeah, let's give it a function to actually set up the class, the ecosystem. So this create ecosystem equal function, and this will have as arguments the main array of the creature, so creature array, and how many creatures, so num c, which will be the number of creatures, and we put actually this for loop, which we created inside the setup function. This we actually now put here inside this create ecosystem, and this will not be 20 anymore, but the number of creatures. So let's create a global variable num creatures equal let's create 100 of them. Of course, it's giving me some error at the moment. And okay, so let's go here, and this is new creatures. Okay, so this will actually fill our creatures array. So then let's create another function, this.update ecosystem. Let's call it so function array as an argument. So this will get our array of creatures as an argument, and let's copy actually this code from the update from the draw function here, and let's actually say array.length as a condition, and instead of creatures let's say array. Now, as you probably notice here, we are passing the array inside and we are filling it. Actually, this should be array, but we are never returning it from this function. And that's because in JavaScript, when you pass an array in a function, you're actually not passing a copy of the array, but the same array. So we're actually passing it by reference. And this means that the array will be filled inside our function, and will be actually the same array outside of our function, will still be filled. Okay, so for example, now we are ready to create our ecosystem object, which will be let's actually create a new ecosystem in the setup. So ecosystem equal new ecosystem. And then let's actually create ecosystem.create ecosystem, and this takes as an argument the creatures array and the number of creatures, so num creatures. Okay, so now our ecosystem should be filled, and so let's actually tell him to post also how many creatures we created. So post r.length, and then let's use another post function to put a new line, and yes, it created 100 creatures. So let's go inside the draw function and say ecosystem dot update ecosystem, update ecosystem, and this will just get the creatures array. And this should work. Okay, yes, so it's working. We have our creatures created inside our ecosystem class. So now inside the setup function, we just empty the creatures array, we create a new ecosystem, and we fill the creatures array with some new creatures. All right. So this was the ecosystem class. We will use it again in short time. So, all right. So now, in order to get if two particles are colliding to each other, so to not overlap, we have to go inside the creature class, and create a function to check if they are actually colliding. So our particle will check if she is colliding with another particle. So let's create it here. Let's actually put the display function at the end of our class. Let's actually create kind of a separator for the functions, just commented little dashes. Okay, just to have it all neatly separated. And okay, so let's create this function, which we will call this.collide equal function, and this will get another particle as an argument. So, and it will go like this. So first we need a distance between this particle and the other particle. So variable distance equal this dot position dot dist. So this is the function that we already just created. Actually, it's called distance squared in the vector class, and let's give it other position as an argument. So this will check the distance between this particle and the other particle. And then let's say if dist, and this is this squared, so let's actually write dist squared. So we are using the form of the function without the square root. So this one here without the math square root, because it's faster. So if this squared is less or equal, so if the particles are actually touching or overlapping, let's say, and they must be less or equal that this dot size, so the radius actually of our particle, our creature, plus other dot size, so also plus the radius of the other creature, and this actually squared, because we are using the square distance, so we also have to square the radius calculation. So if this is true, let's actually say that the color of our particles changes. So this color equal, let's say for example white. So else it will be our usual red. So this dot color equal 1 0 0 1. Okay, so for the red. So let's see, let's actually, okay, so this function is created. Let's now go inside the ecosystem class and create a function to check the collisions. So this dot check collisions. Oh no, actually let's just call it inside our update ecosystem. So let's actually do it inside here, because we will need anyway to have a for loop that goes through all the particles. So let's write actually after our update function. So after we updated it, we will check if our particles are actually colliding with each other. So let's do it like this. Let's create another for loop. So for variable j, we have to call it j because this will be, we already created an I, and so we have to use a different letter. So let's say this is also the same, and then the same length, and then j plus plus. So this is an array inside an array, which means that for every particle, for every creature, we will check all the other creatures and see if they actually collide with each other. So, and then we have to say GRE dot collide, so the function that we just wrote, with GRJ, so with the creature from the other array. And you will see that this should work. Ah, I forgot one thing. So if they collide, let's actually exit from the loop. So they collide, and let's actually break the loop. So this will be break. Oh, no, I don't have to actually write it here. Oh, let's actually do like this. Let's return true from this function if they collide. Otherwise, let's return false. And then inside here, so if they actually collide, let's break the loop. So this will break the J loop. Oh, and now they're all white because we actually didn't check to see if they actually colliding with themselves, because we didn't say something like that. So if E it's different from J, then do all of that. So if we are not checking the creature with itself, then do this. So it seems that there is a problem. Let me check what is the problem. So after a while I found the error. It was a pretty stupid error, as often happens, and it was actually that I put this conditional statement here in the wrong place, because this should have actually been inside the second for loop. So if E is different from J, so if I is different from J, inside the second for loop, then execute the test, so the collide function. And before it was executing was comparing basically the creature with itself, and so it was always white because it was always colliding with itself, of course. Now this algorithm is pretty rudimental, but as you can see, it's working. So when the creatures collide, so when they overlap with each other, they become white. Otherwise, they are red. This is pretty rudimental, and it's not such a good algorithm. It's not so optimized. So we will develop a better version in the future, a bit more complex. But for the moment,